Have you ever wondered how computers could bridge the gap between spoken language and sign language? Today, we're diving into a groundbreaking study from the Institute of Science Tokyo that's redefining AI's role in accessibility. Their system, TeamSign, uses large language models, LLMs, to translate text into fluid, natural sign language videos. Let's unpack how this works and why it's a game changer for inclusive technology. Sign language isn't just hand movements. It's a complete language with its own grammar, syntax, and cultural depth. But teaching AI to replicate it has been a monumental challenge. Traditional methods rely on intermediate steps, like converting text to glosses, a simplified sign notation, which introduces errors. Plus, sign language datasets are smaller and less standardized than spoken language data. TeamSign tackles this by treating sign language as a natural language, something LLMs excel at. Here's the innovation. Instead of forcing the AI to guess every hand motion from scratch, researchers use stepwise prompting. Think of it like teaching a child to tie shoes, breaking the process into logical steps. First, sign language videos are converted into numerical tokens via VQ-VAE, vector quantized variational autoencoder. Imagine turning a video of someone signing into a sequence of numbers representing each pose. Then the LLM learns sign language rules by analyzing text. For example, given "I went to the store yesterday," the model identifies yesterday as a temporal marker, store as a location, and "I went" as the action. This stepwise guidance reduces errors common in direct text-to-video methods. By leveraging the LLM's existing language knowledge, TeamSign generates more accurate, natural sequences. The results? A 18.7% improvement on one dataset and 20.9% on another. Proof this approach works. What does this mean for the future? Better AI tools could revolutionize accessibility, empower the deaf community, and preserve endangered sign languages. It's a reminder that AI isn't just about solving technical puzzles, it's about building inclusive solutions. So next time you see a sign language video, remember, it's not just movement. It's language, and thanks to innovations like TeamSign, AI is finally learning to speak it. Stay curious, and thanks for watching. Ever wondered how computers could learn to sign? Let's explore how researchers are teaching AI to translate text into fluid, natural sign language, complete with those tiny finger movements that make sign language so expressive. The challenge: sign language isn't just big gestures. It's all in the details, subtle hand shapes, finger positions, and facial expressions. Traditional AI models struggled with this, often producing robotic or unclear signs. But the TeamSign team cracked this by combining two smart ideas: repetition loss and large language models. Think of repetition loss as a teacher's note. Don't repeat the same move too much. During training, the model would sometimes quantize signs into the same code, like using the same word over and over. To fix this, researchers added a loss function that encourages the model to use more unique vectors, digital sign language words, keeping signs varied and natural. Then comes the magic of LLMs. These are the same AI systems powering chatbots like GPT. The researchers didn't just use them for text, they taught them sign language structure. By prompting LLMs with sentences like, "I went to the barber shop yesterday," the AI learned to translate words like yesterday or I into signs. But here's the twist: sign language and spoken language have different rules. So the team created auxiliary sequences, step-by-step guides, to help the LLM grasp sign language's unique rhythm and word order. The results? On two major datasets, Phoenix 14T, German signs, and How to Sign American Sign Language, TeamSign outperformed previous models. Metrics like DTWMJ, pose accuracy, and BLEU scores text similarity showed massive improvements. On Phoenix 14T, errors dropped by over 20% compared to older methods. But it's not perfect yet. While the model nails big gestures, tiny finger movements and facial expressions still need refinement. And on larger datasets like How to Sign, the improvements were less dramatic, probably due to their complexity. So what's next? The researchers say fine-tuning to capture more nuance, like hand shapes and expressions, is key. With LLMs evolving, the future of sign language AI looks incredibly promising. Thanks for watching. If you want to see how this tech works in action, check the video demo in the description. And hit subscribe for more deep dives into AI's coolest innovations. Until next time, keep learning. Earlier, we talked about the tiny, precise movements of sign language. But how do we teach machines to read them? That's where cutting-edge research comes in. Scientists are building models that don't just recognize signs, but interpret and generate them with lifelike precision. Take visual instruction tuning, training robots by showing them videos of humans performing tasks. Or VQ-VAE, a system that combines text and images to answer complex questions. These breakthroughs use multimodal learning, teaching AI to process text, images, and motion simultaneously. For sign language, this means analyzing hand shapes, facial expressions, and body language all at once. Some models use pre-training, learning general patterns from massive datasets before fine-tuning for specific tasks, like translating signs into text. Others, like FreeBloom, create videos from text prompts, while Motion GPT turns language into human-like movements. But challenges remain. Studies like vision language models are blind reveal a key issue. AI can recognize objects in images but struggles with context. Researchers are tackling this with techniques like LoRa, efficient model tweaking, and sync, realistic 3D motion generation. These advances aren't just tech, they're about empathy. Imagine real-time sign language translation or personalized educational animations. The same tools powering these systems also help doctors analyze medical images or artists craft digital masterpieces. As models get better at understanding the why behind the what, we're unlocking new possibilities. Whether it's bridging communication gaps or creating art, AI is becoming a bridge between human creativity and machine precision. Stay tuned, this is just the beginning. Thanks for watching. If you want to explore how these ideas work in practice, hit subscribe. And let me know in the comments what AI breakthroughs excite you the most.